Hello, welcome to this edition of Momentum. I'm Robert Green, your host, and happy today to be joined by Dr. David Vandenheever. Dr. Vandenheever is an associate professor in biomedical engineering. Welcome.
Thank you very much, Robert. Nice to be here.
Yeah, glad to have you here. So I know a lot of our students come into biomedical engineering sort of thinking of it as, well, this is the way I'm going to get to medical school. And then some will stay in biomedical. There's a lot will go on to med school. But your background's a little different. You initially were involved in medical devices. Can you tell us a little bit about the work you did there?
Yes, thank you, Robert. Can I start with a quick definition of biomedical engineering?
Absolutely.
So, the traditional definition would be something like biomedical engineering is the application of engineering principles to solve biological or medical problems, for the improvement of healthcare. But following that, I just want to give you my own unique, unconventional definition.
Okay.
So bear with me. Ever since the emergence of life on Earth, 3.8, 4 billion years ago, all life has always adapted to the environment. As the environment changes, life adapts to the environment. That is until Homo sapiens. So humans evolved this ability to change the environment, to manipulate and change the environment to their own benefit, for their own needs and desires. And in a way, an engineer is the ideal manifestation of that. The engineer exemplifies that characteristic as you use your knowledge of the universe to solve problems or just to the benefit for your own desires and needs. And then the biomedical engineer addresses one of the most fundamental needs of humanity, and that is staying alive. And so given that, there's a lot of invention and manipulating the environment, using the knowledge of how the universe works, that's math and science, to design new technologies to make life better, that's more comfortable, but also to kind of, fight against death. And so medical devices is an integral part of that at the moment. In today's day and age, you cannot imagine healthcare without technology. I mean, blood pressure monitors, big MRI machines, CT scanners, ophthalmoscopes, even your Fitbit or smartwatch constantly measures biological signals that you use for healthcare purposes. So, and for me, the future will have even more of this. There will be more technology in healthcare. So making medical devices is an integral part of healthy lives and making lives more healthy, according to me. And it's going to be even more so in the future.
Yeah, I would agree. I mean, that is part of what engineering is making life better and easier for all of us. One of the things I always like to ask is, what got you interested in engineering? I love finding out from people, we always get the math and science aspect, but what was it that said, I really want to be an engineer, and specifically a biomedical engineer for you?
Okay, so just want to preface that by saying I love what I do. I cannot imagine doing anything else at the moment. It wasn't like that from the beginning. Actually, I don't have a good reason for choosing engineering. I think, as is typical of many students probably, I did good in math, science in school. All my teachers, family, friends said, the logical option for you is to go into engineering. My dad was also an engineer. He was a civil engineer. So I kind of knew I did not want to do civil engineering. Buildings, bridges, roads did not get me excited. It was about 20 years ago. Robots got me excited. So I initially got into mechatronic engineering undergrad. My sophomore year, I almost gave that up to do theoretical physics. I was interested in quantum physics. That's a different story for another day. Stayed in engineering, and then getting into biomedical engineering, I was just, again, wasn't a passion at that stage. Just a series of fortunate circumstances, happy accidents. I was at the right place, right time. There was a scholarship for doing grad school in biomedical engineering. It was a new program they started at the university. And I was like, I don't want to go into the real world and work yet. So let's do this. And did master's, PhD. And somewhere in this journey of mine, I really fell in love with research and in the field of biomedical engineering. And this whole idea of using your knowledge of how the world works to benefit kind of humanity.
I love that definition. I think it's important for a lot of our prospective students to understand it. I think many of them have this idea, well, we all knew we wanted to be an engineer from birth and it was just a straight path. But I think in reality, most engineers are like you. It's a series of happy accidents that get us to where we are. That's great. You weren't educated in the United States. You grew up and went to college in South Africa. Now you're a professor here at an American university. Any significant differences between the two educational systems? What was it like growing up in South Africa?
South Africa is a lovely country. Enjoyed it, loved it. But there are big differences in the educational system, especially in engineering. That's actually the only one I can really talk about. Engineering in South Africa, for me, was a lot more a more rigid structure to what you're doing. Mm-hmm. You walk in there day one, and they basically give you your class schedule for the next 4 years, no choices. This is what you do, 8 to 5 every day for the next 4 years. What I like about what I see here is there's a lot more freedom in choosing electives, getting exposed to different fields outside of engineering. My education was engineering, science, maths, engineering.
Yeah.
So I like what I see here. I've been here now for about 2.5 years, and it's been an eye-opener in a way.
Well, how did you get to Mississippi State from South Africa?
Yeah, good question. So I see myself as an ambitious person. I've always been ambitious. I still am. I want to make an impact in the world. Really want to make a difference. And I always knew that to really do that, I need to go somewhere where there are more opportunities to make a real impact, and somewhere with the kind of the necessary resources to really make an impact. I'm not saying South Africa does not have that, but it's a bit more difficult. There's a lot more opportunities in the US. So I always knew I wanted to go somewhere else.
Okay.
It wasn't until COVID, so lockdown, COVID, in the house, my wife and I started talking, and I brought that up, and she said she's in the mood for a new adventure. We've always loved traveling, and we decided this is a good time. I mean, let's start looking, and applied sort of all over, mostly US and Europe. I was picky in the sense that we did not want to live in a big city. We wanted to, live at our own pace. And I wanted a research position where I had power in the research I do. So Mississippi State just fit all of that. I applied and had the interview. I flew over to the US during COVID. I mean, we were probably 2 people on a big passenger plane. And what helped sell it to my wife was her best friend at that stage from South Africa was doing a postdoc at UAB in Birmingham. So it all just made sense. It all kind of just clicked, and we said, all the science points towards this.
Yeah. So you've moved from medical devices now into neuroscience, and I know you have the Neural Engineering Research Division, or the NERD Lab, which I think is a really cool name. Tell us a little bit about what you're doing in terms of neuroscience research.
Yes, so obviously I first had NERD, and I had to work backwards to fill in the letters to get it.
It always works that way, yeah.
So I switched to my focus more towards neural engineering. So you mentioned I did a lot of medical devices, and so I gained a lot of experience recording and working with a lot of different biosignals. But I settled on EEG, so it's electrical brain activity, analyzing those signals, just because I've always been interested in the brain, and sort of on the side. I always read books about how the brain works, really interested. And at some stage I realized that I can do this for a living. I can make my hobby and passion my work. And I switched my focus to neural engineering. And so the one aspect, there's kind of two phases or two arms to this. The practical side, the engineering side is recording brain signals and looking for, so you can do diagnostics. So looking for biomarkers associated with specific mental disorders. So that's some of the research we do. Look at ADHD, depression, anxiety to diagnose and monitor, but also to better understand these disorders. We also do neurofeedback, where you can use the brain signals to train the brain, which you can use for treatment or rehabilitation of disorders. And then a last example is kind of the typical engineering, neural engineering one, and also biomedical engineering is brain-computer interface, where you try to decode the intention of a person based on their brain signals to control an external device. So, a typical example would be to use your brain signals to control a wheelchair or a robotic arm or, full body exoskeleton.
Okay. We got about 2 minutes left. So you sort of move from the practical, I guess what most people think is engineering, sort of typical engineering of devices, to more neuroscience, something more theoretical and fundamental. Can you talk a little bit about the role of engineers in that theoretical, fundamental type of research?
Yes. So again, I've always been interested in the brain, how the brain works. So some of the research we also do and look at is really fundamental questions. I mean, do we have free will? You can start looking at that scientifically. And just consciousness, understanding consciousness, how the brain produces consciousness. And I think there's definitely a big role for engineers to play in fundamental research. I mean, it's good and dandy for philosophers and theoretical physicists to sit in, their armchairs and think out all these crazy theories, but you need engineers to help build experiments and experimental design to help prove those theories. And I just want to give you one or two examples of that really exemplifies this and showcases this. And something like the Higgs boson. It was a theoretical idea more than 60 years ago. It took something like the Large Hadron Collider, a big engineering feat to kind of prove that. And the same with gravitational waves. The LIGO test they did with the LIGO facilities, where they measure change in distances smaller than 10,000 times smaller than a nucleus. And I mean, that's an amazing engineering feat. You need engineers to do this.
Yeah, we certainly do. Well, we're happy to have you here. I'm sorry we're out of time because I know there are a lot of things we could talk about, from philosophy and ethics, and I know you've taken a lot of courses in that, but I hope our current students will look you up and look into the type of research you have, and some of our prospective students will come here to find out what all you're doing. I want to thank you all for joining us on this edition of Momentum, and I look forward to seeing you next time.